everyone, myself Varsha. I'm from Shri Venkateshwara College of Engineering. Today we'll be talking about low power VLSI design. Introduction to low power VLSI design. VLSI design focuses on reducing power consumption in integrated circuits. Energy efficiency is crucial for extending battery life in portable devices. Techniques such as voltage scaling and power are commonly used to achieve low power consumption. Importance of low power design in VLSI is that low power design reduces operating cost and environmental impact. It enables longer battery life and smaller form factors. Increased power efficiency can lead to deserved performance and reliability. Challenges in low power VLSI design is that balancing power consumption with performance and area constraint, minimizing leakage current in transistor to reduce static power dissipation, managing dynamic power consumption during the power operation. Low power design space, there are three parts that we can perform low power techniques to reduce power dissipation: voltage, physical capacitance, and switching activities. Techniques for low power VLSI design is that clock gating, that disabling clock signals to unsend circuit blocks to reduce dynamic power. Voltage scaling is that adjusting power supply to optimize power consumption. Power gathering, that is the shutting off of the power to inactivate block to reduce leakage current. Integrated clock gating is that we take the D latch which has enable and the clock connected to the enable. The output is connected to the AND gate, and the final output is given as the gated clock, which has the code of always begin if the knot of clock and the latch enable is equal to enable, and the gated clock will be equal to latch enabled, which is multiplied with the clock. Power management strategies is that the dynamic voltage and frequency scaling, that is DVFS, to adjust performance based on workload. Heterogeneous computing to allocate tasks to energy efficient process. Adaptive voltage to scaling to dynamical adjust voltage based on workload. Design of low power consumption, utilizing power efficient circuit topologies and architecture. Implementing data compression technique to reduce power consumption during data transfer, and incorporating low power design libraries and broad cells in design flow. The low power design flow has the system load specification, fabrication, and also system load power analysis. Based on the flow chart, we design the low power design flow. Verification and validation of low power designs. Power analysis tools to estimate consumption at different stages, simulation and emulation to validate power management technique. Post silicon power profiling to verify the power consumption in real world. In the diagram we see that the SOC use case model and the IEEE 1801 UPF, which is connected to the UPF parser, which is then connected to the SOC low power model, and these two combined together are power supplied to the generator, wherein generator the SOC scenarios and SOC low power scenarios are submitted to the SOC power aware scenarios, which is then converted to four topologies, whereas the virtual platform, the simulation platform, the HV Excel emulation platform, FPGA silicon platform, which are all together submitted to the coverage. Emerging trends in low power VLSI design is that the energy harvesting for self-powered IoT devices, approximate computing of energy efficient computing, neuronomic computing of low power brain inspired architectures. Case studies in low power VLSI design: mobile processors with advanced power management feature, IoT devices with ultra low power consumption for low battery life, wearable devices with energy efficient sensor processing unit. I conclude that the low power vlsi design is essential for energy efficient and sustainable electronics. Continuous innovation and research will dive into the further advancement in low power designing. Collaboration among designers, research, and industrial stakeholders is the key to achieve the power goals. Thank you.